Okay, guys, I'm going to go through the review with y'all question by question. Now, some of these I'm going to do straight on top of the review that is sitting here on this Word document. Then some of them, for example, 3, 4, 5, and 6, I'm going to do on a just blank Word document so y'all can see what I'm doing. And then the rest of it, I believe I should be able to do on here. But I'm going to go through these answers with you. If you still have questions after watching this video, message me on Remind, because I get those notifications more than I get the email ones. Message me on Remind your question, and I will try my best to reply to you as fast as I can before you take your test. Your test does need to be completed by the end of September 3rd, I believe, by 11:59. It's going to close. So you will not be able to take it yet on September 3rd at 11, actually maybe 11:45. I don't know if Microsoft Forms will let me go to 11:59. But the test is going to close, so you need to take it before the time is up. Message me if you have any questions before you take it. And it is on Microsoft Forms. If the images do not load, click refresh. It should not submit your form. If you have problems with the form, please email me. You can only submit it once, so I need to know. So first, we're going to look at this piecewise function, which that disappeared. I'm going to zoom in a little bit for y'all. So we're going to complete the table and then sketch a graph that represents the function. So Rosa saved $100 to spend on vacation. So that means that we're starting on day 0 with $100. And then for the first 3 days of our vacation, she spent $20 each day. So we are then going to have minus 20. So 100 minus 20 is going to give us 80. And we're going to have minus 20 again, giving us 60. And then minus 20 again, giving us 40. And then for the next 2 days, she spent nothing. So we didn't spend anything at all. So we're going to have that minus 0 and have 40 again. Minus 0 and have 40 again. That was for those 2 days. And then after those 5 days, she spent $10 each day until her savings were depleted. So that means our savings got down to 0. So we're going to spend $10 a day. So we're then going to subtract 10, have 30, subtract 10, have 20, subtract 10, have 10, subtract our last 10, which gives us 0. So then we are going to graph these points. So our graph does not show on our y-axis that we go all the way up to 100, but it's understood that this top line right there is 100. So we are going to graph 0, 100, because these are our x values and these are our y values. And so we're going to plot these points. So we have 0, 100 all the way up here at the top. Then we have 180 right there. And then 260 right here. 340 right there. And I'm going to go ahead and connect those dots, because then so that's our first piece of our graph. That's what makes these piecewise functions, is because we're graphing different pieces. So, and then we will be at 40 and so we have 440, 540. Again, that's our second piece right there. So that's why this is a piecewise function. And then at 6, we go down to 30. At 7, we go down to 20. At 8, we go down to 10. And at 9, we're finally at 0. So that is how you get your table and graph those. So because we saved $100 to spend, we're starting with $100, and then we go down throughout all that. So now let's look at number 2. And I believe it's Belinda is saving money for a new snowboard. She earns $30 every 5 days she tutors. So every 5 days we earn $30. After 30 days, she takes a break from tutoring and does not earn any money for 10 days. So whenever we're starting tutoring at 0 days, we have not tutored yet, we're going to have $0 because, sorry about that. We're going to have $0 because we haven't earned anything. We haven't tutored at all. And then after 5 days, we're going to have $30. And then another 5 days, so we're going to add 30, which we added 30 here as well. We're going to be up to 60. Then we're going to add 30 again, be up to 90. Add 30 again, get me to 120. Add 30 again, which I believe gets us to 150. And we'll add 30 one more time because remember, we're tutoring for the first 30 days. And that will get me to 180. So, and then we take a break for 10 days. So we take a break, so we're going to add nothing. Add 0 and add 0 again because we got to get the full 10 days. And then after those 10 days, we begin tutoring again. And every 5 days again, we earn that $30. And then eventually we reach our goal of those $300. So we're going to add 30, get to 210. Add 30, get to 240. Add 30, getting us to 270. And then add our final 30, which gets us to 300, which was our goal. So whenever we're graphing this, again, these are our X values and these are our Y values. So we're going to plot those points on here. And that first point that we got was 0, 0. And then I'm going to graph every 10 points. So 10, 60. And I believe these go by 20. So 20, 40, 60. Yeah, these go up by every 20. So, and then at 20, we're at 120. So we're going to go here. And then at 30, we were at 180, which will get us to there. So then I'm going to graph those little parts because that's our first piece. That's why we were adding those 30. And then for 10 days, so we'll be at 40, we didn't earn anything because we took a break from tutoring. And then finally, we were adding the $30 again. So let's look at 50. We were at 240, which I believe is right here. Yeah, that's correct. And then that last little piece from 60, we were at 300. So that's our graph. And again, this is a piecewise function because we are graphing different pieces of different lines. Because if we were to write the equation for these, this first little section right here would give us one line, that section would give us one line, and then that final section would give us another line. So, and then we're going to get to number 2 and 5. So let me open up and pull another Word document. Let me see if I can get these to share screens. All right, so we're going to write a piecewise function to represent the data shown in the table. So the first thing that you need to determine here is for what pieces are we looking at? So we need to determine how we get from 60 to 55. So to get from 60 to 55, we didn't add 5, we subtracted 5. So we subtracted 5, and then from 55 to 50, we subtracted 5. We subtracted 5 again. And then once we get to 45, we're not subtracting anything. We're subtracting 0. Oh, wait, not there. So then at this point, we're subtracting 0 to get from 40. We're not subtracting 0. We're subtracting 2 to get from 45 to 43. So we're going to subtract 2 again, and subtract 2 again. So that is showing us our different pieces. So for one piece, we're subtracting 5. Then we're subtracting 0, and then we're subtracting those 2's. I have no idea what that noise was. But so whenever we're writing a piecewise function, how that's going to look, zoom a little bit on this page. Let me get the pen over here. So we're looking at whenever we would write f of x equals, And then we would have a really pretty curly bracket, which I struggle with writing. So then we have those curly brackets there. And we would write the equation for that part of our line or our piece. And then we would write the domain for that piece. And so this is where I'm going to go over all of that. So to get our line here, as y'all hopefully remember, we would have to look at that y2 minus y1 over x2 minus x1, which was our slope. I have a little m equals there so y'all can determine what that is. And for our first piece, I'm going to look at our first 2 points there because those are generally the easiest to look at. So this is not letting me write. There we go. So our y2 here, so we're looking at the points in the order of this is our first point and that's our second point. So our first point here, or our second point for our y values, that's 55. And then our first point y value is at 60. And then we have our first x value and our second x value. So we would have 55 minus 60, and that's going to give us that -5 because we'll have that -5 there, and then we'll have 1 minus 0, which gives us 1. So our slope here is -5. So we have -5x, and this was an easy one for us to get that y-intercept for because of that 0. So we know that that touches our y-axis at 60. So once we know that, we then got to talk about the domain of that piece. So we went from 0 to 3, subtracting 5. So we're going to start with that 0. And we are going to include it in the domain for this because to get that 60, we would plug 0 into -5x plus 60, which would give us 0 plus 60, which would give us 60, which is our y value there. And we would then also include 3 to get our 45 here as well, because again, we were still doing that. We were still subtracting 5 each time to get that 45 there. So we're going to include it in that equation. Now, so for the next little piece, which I'm going to change pen colors so that y'all maybe help you out a lot. So we're looking at whenever we were not adding anything. So the parts where we were not adding anything was 4 was from 4 all the way down to 6. So, and this is kind of, again, an easy line to look at because it's going to be a straight horizontal line if we were to graph that because our slope, we're not going up by anything. So our slope here would be 0x plus our y-intercept, which here would be 45 if we kept that line going. But we don't have to include that 0x because we're just talking about our horizontal line here. But so for our domain, we're going to start with 3, but we're not going to include 3. And the reason for that is because to get our third value right here, we subtracted 5, but we need that third value to get our fourth value, fifth value, and sixth value. So we're not going to include it, but we are going to include it in our domain because we have to have it to be able to get the rest of those values there. So, and we subtract 0 all the way until we're at 6, and we are going to include 6 because we subtracted 0 to get that sixth value, which is right there. So, and then let's change pens again. Let's just change the color of this one to orange. So the next little part that we're going to look at is that from 7 to, ooh, that's a really thick pen. Let's go down on that. Let me erase that. So we're going to go from 7 to 9 now is where we're looking at because that's where we started subtracting 2. And again, you could come over here and let me change this pen to orange too. So we could keep going, so we could do the m equals y2 minus y1 over x2 minus x1. Or hopefully you notice what we subtract by is also going to be our slope here for these. So it's kind of an easy shortcut way to get your slope on these. So we're going to look at negative 2x. But here we are going to have to find that y-intercept. So maybe y'all remember how we were taking the points and taking our slope and going from those points. So we were looking at, we'll go from 743. So in here, we're going to have to go down a lot of points to get to our y-intercept because we're at 7. And if we were looking at our y2 over x1, so our y value is negative 2 and our x value is 1. So we're having to go down by 1 each time to get there. Let me scroll down a little bit. So let me leave that there actually. So I'm going to subtract 1 and add 2 because we're going backwards. So we're going to do the opposite of the sign that's up here. So that's going to get me 645, which is the correct point because it's the point that we share with that previous line segment. So that is the correct point. So that's a way to know you're going in the right direction there as well. So and then we'll subtract 1, add 2 again. We'll be at 547. Subtract 1 again, you'll get 4. Add 2, you'll get 49. Subtract 1, you'll get 3. Add 2, you'll get 51. I'm going to go up here so y'all know where I'm going. Subtract 1 again, I'll get 2. Add the 2, you'll get 53. Subtract 2 again, you'll get, add 2, subtract 1, you'll get 155. And then finally subtract your last one, and you'll get 57. So 57 is going to be our y-intercept here. So plus 57. And then now we got to talk about that domain again here. So whenever we look back over at our table, we're touching that 6 again. So we're going to have that 6 as a part of our domain, but we're not going to include it because to get that 6th value, we're going to use that f of x equals 45 there. We're not going to use the negative 2x plus 57. But we are going to use the negative 2x plus 57 to get that 9th value. So we are going to include it. So your final answer here would be this equation. That is your equation of your piecewise function to represent the data shown in the table. So that would be your final answer for number 3. All right, so I'm going to scroll down. I wonder if I can add a new page. Yeah. There we go. So we got our new blank page. This is where we're going to be looking at number 4, which here I should probably label that one as number 3. This is where we're going to do number 4. So let's look over here again at our table. So to get from 80 to 75, to get to 75 from 80, we subtracted 5. To get from 75 to 70, we subtract 5. 70 to 65, we subtract 5. So that is our first piece right there because that's where we're continually using the same thing to keep going. And then finally, to get from 65 to 64, we subtract 1, we subtract 1, we subtract 1. And then finally, to get from 60 to 58, we subtract 2. So that's going to be a very small piece there, but that still is a difference there, okay? So if we're going to go over here, and again, we're going to write that f of x equals, and then our big, nice curly bracket. And we're going to look at our pieces. So our pieces, again, are that we're subtracting the same number for. So our first piece here is going to be that 0 to 3 because we subtracted 5 from each of those to get there. So again, if you wanted to, you could do the y2 minus y1 over x2 minus x1, or you can use the nice little shortcut of we know the slope there is going to be negative 5, and then we'll have our x because we're subtracting 5 each time and we're going down by 1 So the reason that we can do this, which let me point this out as well. The reason we can do this is because our x values are going up by 1. If our x values were going up by a different number, we would need to complete this. But because our x values are going down by 1 is why we can use this little easy way to get our slope. And then again, for this first one, we have our 0 value, so we know that our y-intercept is 80. So, and then we're going to have to talk about our domain again. And as you see, so let's get back to looking about that domain. If you can hear the rain and the storm outside, so I had to stop and now I'm coming back. Okay. So now I'm probably going to write the domain a little bit lower right here, but it is typically beside it, like it was up here. I just kind of wrote this one a little bit farther over. So for the domain for this first piece right here, we're going to have 0, and we're going to include 0 because we would use this equation to get our value f of x for 0. And then again, we are going to include it for that 3 that was what we went to because we used that -5 to get to that value. So we're going to include that 5 there. And then let's switch pen colors again so y'all can kind of see the different pieces. And these are why these are called the piecewise functions, like they are. So our next piece starts here. Where do we go? We went all the way down to 60. So in this part, we were going down by 1. So we're going that -1x, and you can have that 1 out there if you would like, but it's not necessary because it's understood that there's a 1 there. And then we got to get our slope again. So this time, for whenever we're looking at our points, and I'm going to start with that 464 here, because if we go down correctly, we should get 365. So we're looking at -1 is our slope. So -1/1. So for our x values, we're going to subtract 1, because remember, x is on our bottom, y is on our top, and we're going to add 1. So we should get 565. We're subtracting 1 here, not adding 1. So actually, you're going to get 365, which is that previous point, which is exactly what we wanted. So let me scroll down a little bit. We're going to subtract 1 again from our x, giving us 2, and add 1 to our y, getting us 66. And we're going to complete that again for 167, and then 068. So I'm going to scroll back up, and our y-intercept was 068 here. So we're going to add our 68. So, and for our domain here, earlier I convinced y'all that we were going to end at 5. We're going to end at 3, not at 5. Apologies for that, because we go down to our third value right here, not 5. 5 is, we were subtracting 5 is why I did that. Apologies. We're going to include 3, not 5. So, but then for our domain down here, we're going to start at 3, because we had to have that third value to get our fourth value. But we are not going to include it because to get our third value, we're not going to use this part of our line. So we start at 3, and then we end at our last one where we subtracted 1, and that was 8. We are going to include 8, though, because we had to subtract that 1 to get that 8th value. And then finally, our last little piece. Let's go ahead and switch to orange. So, and at this point, and again, we're going to kind of use our little, kind of like a cheat to get our slope here. So we're looking at -2 for that slope for that last point. And then we're going to look at our points again to determine where our y-intercept would be. So our point that we originally start with is at 958. And we're looking at -2/1. So we're going to subtract 1 and add 2. So we'll be at 8. I'm going to add 2 to get us to 60. Which when we have 860, that would be our previous point, and that's where we're starting with at this line because we had to have that 8th value there. So, and then let's look at, we'll get us to 7, 62, 664, 566, 468. Then I'm going to go up here. We'll get 370. 272, 174, and then finally 076. That's an 8, not a 6, but it should be a 6. We're adding that 2 again, so we'll get 76. So our y-intercept here is that 76. And again, for the domain, when we're looking at it over here, we have to have that 8th value to be able to get to this next part of our graph. But we're not going to include it because to get our 8th value, we subtracted 1. But we are going to include it for that 9th value because that is where we got that 9th value was from that minus 2 right there. All right, and I'm going to insert another page. Oh, it inserted in the middle, but that's okay. Then I'm going to come over here and we're going to move down so that we can see number 5. Y'all can probably definitely hear that rain. It's really coming down. So when we're looking at number 5, and I'll probably highlight some good information over here. So a jewelry store offers reward coupons to its customers. A $2 reward coupon is awarded for each $20 spent. I don't know why this is. Okay, so for each $20 spent, write a function that represents the value of reward coupons awarded for up to $100 spent. So, and for this one, we're writing a step function. So, if y'all remember what the step functions look like, they looked like steps. So it's a bunch of horizontal lines where the domain is for just one certain segment of the line. This isn't going to be a straight line. It's going to look like steps if we were to end up connecting all the points. But we're just going to write a step function. We're not going to graph it. So if we come over here, go back to the red pens. This is for number 5. So whenever we're writing a step function, it looks very similar to a piecewise function. It's just in this one, we're just looking at horizontal lines instead of lines that actually have a slope. So if we spent $20, we are then going to have a $2 reward coupon. So we're wanting to get to reward coupons for up to $100 spent. So I'm going to kind of write our domain first. So whenever we spend $20, so actually we get it at $20. So so since we get our first coupon, which is giving us our first $2. So to get to $2, then we got to spend 20. So we're going to include 20 and not include 0, because if we spend $0, we're not going to get that $2 coupon. And then, so whenever we get we'll have $4 worth of coupons is when so it's going to be after we've spent $20, but it's not going to be until we've spent $40 because we have to spend $20 more. And then we'll have $6 because, again, we're adding 2 each time. We're getting another $2 coupon. And we're not going to be at 40 because once we've spent over 40, it's going to be when we get to 60. And then we'll have $8 worth of coupons, and that'll go from 60 to 80 because we spent $20 more. And we'll have 10 coupons, and that'll take us to finally when we've spent $100. So when we spend $100, we'll have those 10 coupons there. All right, guys, so let's now look at number 6. I'm going to go all the way down here and add a page again. And hopefully, see, this one got added in between 2. That's weird. But now we're looking at number 6. And again, we're just writing a step function. So it says horizontal lines again. So all we're looking at is those y-intercepts because we don't have a slope. We're talking about horizontal lines here. So a kid's bouncy house charges $8. Ooh, it's supposed to be a highlighter. which is $8 for the first hour and $2 for each additional hour of playtime. Write a function that represents the charges for up to 5 hours of playtime. So we're going to come back over here. And so what we are controlling here is that cost. So, and what we control is always going to be in our y-axis. So for the first hour, we're going to charge those. Oh gosh. Ooh, where did we go? Here we are. So for that first hour, we're just going to change. Why is this still doing highlighter? I clicked pen. Y'all saw me click it, I thought. Okay. So for that first hour, we're going to charge $8. So that's going to be from 0 to 1, because we're going to be if we were to graph this, our y-axis would be in hours. The reason we are not including 0 is because if you haven't got on the bounce house, you're not going to pay anything. It's the point at which you step on the bounce house that you pay. So for that first hour, we're charging $8. So if then we wanted to jump for another hour, so this would not include 1, because if you're in that first hour, you're just going to pay $8. If you jump for a second hour, we are going to charge $2 additional. So you would then be owing $10 total. So, and then we'll go to the next one, and we're not going to include 2, because remember, for that second hour, you're just charged 10. But then for the third hour, for when we, right after we start at 2, all the way until 3, we would then have to pay $12, because at that point, we are jumping for another hour, and again, we would have to add $2 more. So then we would add $2 more to jump for another hour, so we would not include 3, but that would get us to our 4th hour. We would add 2 again, and that is what would finally get us to our 5th hour. All right. And I think that was all I was going to do on this other Word document. So I'm going to go ahead and minimize this and make this cover my whole screen again. So if we were given f of x equals the absolute value of x. Okay, so I'm going to graph the absolute value of x because I know a lot of people are struggling with this. So whenever we were going over absolute value in class, we were looking at x, and I'm going to draw a little t table over here, and f of x equals the absolute value of x. And if y'all remember doing these in class, let's look at -2, -1, 0, 1, and +2. And these are just the basic points for an absolute value graph. So if we take the absolute value of -2, we would get +2. For -1, we'd get the absolute value of -1, we get +1. Absolute value of 0, we would get 0. Absolute value of +1, we would get +1. And finally, absolute value of 2, we would get +2. So then if I come over here and I graph those points, which actually I'm going to zoom in so that y'all can see this better. So if you were to draw straight lines, unlike me, the absolute value graph is always going to look like a V. It is always going to look like that. That is our parent function right there of a graph. It looks like a V, and those are our points that we would graph if I just asked you to graph the absolute value of x. So, but for this one, we're graphing g of x, and it's f of x with that -3 inside those parentheses. And if y'all remember, if we were looking at g of x, we had plus or minus a out front, and then, which I'm going to write it in that form. Let me make this a little prettier. So we would have f of x minus c, and then plus d on the outside. So with that 3 being in there, it's that minus c. So our c value here is actually 3, but how I told y'all, if we were looking at it like we are up here, you're going to think the opposite. So that negative, we would know that we're going right. And then again, pull up that Word document again. So if we're looking at our literal c value too, you can also notice that we're going to go, which I drew a left arrow and said right, but we're going to go right. And if you look at your literal c value, that'll also tell you we're going to go right 3 units. So you would come over here, and I always like to take the point 0, 0 and move it first. But you would take that point and you would move right 3 points. You would take this point and move right 3 points. That point and move right 3 points. This point right 3 points. And then finally, that last one, write 3 points. So I know a lot of y'all were struggling with this. And on your graphs too, don't forget your arrows on your ends. These do go on forever and ever and ever. If you were to not have those arrows there, technically it's not correct. I have been nice though and not been taking off points, but do not forget your arrows there. And also when you're graphing the absolute value, you need those 2 points to the left of your little bounce, and I call that a bounce point because that's the point at which we change directions. You would need that little bounce point and then two dots to the left and 2 dots to the right there is what I would need for that graph. So let's zoom back out a little bit. So and then here we're looking at the distance a runner travels over time during a race. This is a piecewise function. And the reason for that is we have different pieces. And then finally, let me change this pen. Let's see, let's go to purple. Go down one more, maybe skinnier, but. So we have 4 different pieces there. And we're asked to write a function f of x to define the variables. So when we're asked to write the function, we're going to be doing exactly what we did earlier. We're going to be writing our f of x equals with our curly bracket here. Okay, so if we're looking at our first little piece right here, we're going to take that first little value and that last little value, and we're going to have to do that y2 minus y1 here over x2 minus x1. So let's list those points. And that first point is, why's my pen not working? Oh, I bet you it thinks I'm typing. There we go. Okay. So our first point there is 0, 0. Very easy point. Our next point, oh my Lord, this thing is getting on my nerves. Our next point there is 15, and then we're at 1.5 for that y value. So whenever we're looking at our y's, we're looking at 1.5 minus 0, and then 15 minus 0. So that is going to give us 1.5 over 15. And hopefully you see the problem there that we have a decimal in our fraction, and you would then put that in your calculator. So 1.5 divided by 15 is then going to give us 1/10 is our slope there. So our slope here is that 1/10 x, and then hopefully you notice our y-intercept there is 0, 0. So then let's look at the next little point, and I'm going to erase this over here, so if you need this, pause the video. And we are still looking at that point of, because I put my arm over there, I know why it happens, but getting on my nerves. Because if I put my arm down here, it pulls up other stuff. So again, we're looking at that 15, 1.5. We're going to look at the next little piece right there, and then that is at 32. So on the top half, we'll have 30 minus 15, and on the bottom half, we'll have 2 minus, did I do that first one right? Yes, I messed up this one. I put my x's on top. Sorry, excuse me. I'm being distracted by the storm. So our y values, I wrote that second point wrong. That's actually why. I'll probably in the video. No, I did write that correctly. Sorry. You'll ignore me. I'm going crazy. So we're doing 2 minus 1.5 over that 30 minus 15. So on the top, you're going to have that 0.5, and on the bottom, you're going to have 15. So you'll have 0.5 divided by 15, which gives us 1/30. So we're looking at 1/30 x. And here is the fun part, is that we got to then take points to determine our y-intercept for that little line segment right there. So let's look at that first point of that. So we'll look at 15. 1.5. And so remember that our y's are on, okay, we'll see that. Whenever we're looking at this, it's y over x. So for our y value, or for our x values, we're going to be subtracting 30, and then that's going to get us past that. Okay, so because that 30 is going to get us past our y-intercept here, we're going to cut this in half. So we're actually going to subtract 15. Instead of subtracting 1, we're going to subtract that 0.5. So we're going to use this point right here to get us to our y-intercept here. So that would end up giving us 0, 1. So our y-intercept there is 1. So use your original point for that. Don't keep going. You need your simplified answer for your slope, but use your original answer to be able to get your y-intercept here. This is one of the more difficult problems we've done. So then for that next piece right here, we're going to keep using these points. And again, if you need what I have up here, go ahead and pause the video because I'm about to erase it. So we're again still looking at that point, 30,2 and 45. And I believe that that is at 4.5. So y values on top, so 4.5 minus 2 over our x values on the bottom, so 45 minus 30. So on the top, you are going to have 2.5 left. And on the bottom, you are going to have 15 left, I believe. Yeah, 15 left. So that would end up simplifying to 1/6 for our slope. And we obviously don't have enough room here, so I'm going to keep writing down. So for this third piece here, our slope is that 1/6 x. And remember, we got to do those points again. So we're going to use our first point here. And actually, because we're looking at y over x, and we want to get our y to 0. So yeah, so we're still going to use that first point. We're going to use that 30,2. But this time we're actually going to use this simplified point over here to get us there, because we'll have that y minus 1 and that 30 minus 6, which was going to give us 24, 1. And then we'll do that again, that minus 6. And that'll get us 18, 0. So our y-intercept here is that 18. And then finally, for that last piece, and again, if you need what's up here, go ahead and pause because I'm about to erase it. I'm going to do one more piece here, and then we'll be done and ready to answer some questions. So for that fourth and final piece, we're going to talk about that point and that point. And I do believe I'm going to erase so I can make sure I see that point clearly. That was at my 45, and it was 4.5, I believe. Yeah, so 45, 4.5. And that final point is at 66. So y2 minus y1 over x2 minus x1. So that is going to give us 1.5 over 15. And then that simplifies to 1/10. So our slope here is that 1/10 again. Remember, we got to find our y-intercept now. So we're going to look at some points, and then we'll go, let's see, for this one, I think it's going to be best to use that 1/10 and go from 60. That'll probably be the easiest math that we can do. So we'll subtract 10 and subtract 1, giving us 50 and 5, 44, 33. If you see where this isn't going, what do you think our value is going to be? And so we end up getting to 0, 0. And the kind of crazy thing here is that the little first part of our piece here is the same as our piece. So our y-intercept here is plus 0. But that is kind of irrelevant, as we all know, and I should have done as we go on, but I forgot to do the domains, but we can always go back and do them. So we can just look at our pieces up here on the graph and see where they started. So for that first one, we started at 0. So we're going to include 0. And we ended at 15. And we're going to include 15 in this first piece right here. And then our second piece started at 15, but we're not going to include it because we included it in our first piece there. So we're going to have 15x all the way until 30. We're going to include 30 here. We're not going to include 30 here because that's where the last one ended. This one all the way to 45, which we'll include. And then from 45 to 60, and we'll include 60 and not 45 because it was included in the previous one, okay? So again, go ahead and pause this if you need this. I don't think I can move it all up, so I'm going to have to erase part of it. Actually, you should have your review, and I'm going to read the question off of my sheet of paper that's right here, and we'll answer it just below here in a different color. And we'll put our answer over here. Okay. So is it true that the speed of the runner was greatest from 30 to 45 minutes travel? So 30 to 45 minutes. So right here, 30 to 45 minute interval of the race. So what it's asking is if that was when our speed was the greatest. And that actually is when our speed was the greatest. You can tell that by looking at the slope on the graph. And you can also tell that by looking at that was our fastest slope there as well. So the answer is yes. And you can say because of the slope. Oh, I was going to do that in orange. You know what it is though. So then our next question, is it true that the 15 to 30 minute interval, so let's scroll up and look at that. 15 to 30 minute interval of the race, the runner ran a total of 2 miles. So whenever we're talking about our distance in miles, that's on our y-axis here. So we started here at like 1.5 and we ended at 2. So did we run a total of 2 miles? The answer for that is no. We only ran, what was that, half a mile? We only ran half a mile. All right, and then we're going to go down here to 9. And we're back to talking about f of x equals the absolute value of x. Consider each transformation and describe how the transformations affected f of x. If you need a review on this, I would flip back into your book. Here, I have my book right here. Let me look up the page. It was page M3-17. That's the activity 1.3. We wrote a few little notes there. And if you need a refresher on what our A value does, our C value does, and our D value does, flip to the pages before or look in your notes, okay? I think this has been where most people have been struggling here. So we're going to describe how the transformations affected f of x. So what I would personally do is I would go in here and look at my new differences. So for A, it's that 2 out front and then that plus 1 on the end. So that means that my A value here is 2 and the D value is positive 1. So that A value means that we are going to vertically stretch. And I think vertically also only has one L. Sorry, guys. It's vertical stretch. That's just what we'll call it. Let me move you and stretch down here. There's also a T in stretch. Sorry, guys. My spelling it this late at night kind of gets a little crazy. All right, so there we're vertically stretching, and that's by a factor of 2. And then we are going to go up 1 point, and that's from our D value. So if we go over here and look at B, so for B, we have an A value of -1/2. So that -1 there is going to cause a reflection. And that line of reflection there would be y equals 0 because we're not going up or down at all. And then that 1/2 is also going to cause a vertical dilation. And that's by a factor of 1/2 there. So that was when we pulled our graph wider. Was another way y'all could look at it. And then finally, if we come down here and look at C, we have that negative out front and that +2 inside. So our A value here is -1, and our C value, and remember this from the form, and again, that form is shown very well on page M317. It shows you that we have on the inside, it's X minus C. So our literal C value here is -2. So we have a reflection. Again, our line of reflection is going to be y equals 0 because we didn't go up or down at all. And then that C value, if you're looking at the literal C value, you're going to do the same. So we're going to go left 2. Or if you're looking up here at your equation, remember, we're going to think opposite, and that's another way that you can determine that left 2. And then finally with D, we're looking at that 1/4 and that -5 outside. So again, here we have a vertical dilation. And that was when we would get wider, and that was by a factor of 1/4 here. And we would go down 5. That's our D value. So I'll put up here A equals 1/4, and D is -5. And so that D value takes us up or down. And those A values, that's really, I think, where most people are struggling with the vertical dilation, vertical stretch, and then the reflection there. So that would be a very good thing to look over right before your test. And then finally, we get to number 10, our last question here. And it was, what is the domain of the function in terms of the problem's situation? So that is talking about our whole function here, the whole graph, which I forgot to read up here. The graph shows the distance D of a bus driver from her home over time T during her shift. So this is very similar to that one that we did in class about the basketball players. So our overall domain, and domain is our X values that we have shown on our graph. So we're starting at 0, and we're going to include 0 because we have a distance at 0. It's 0. And we're going to have our X value, and we're going to include 8 because we have a distance at 8 hours again. It's when we're back at home, our distance is 0 again. All right, and so now we're going to look at our pieces. Oh, fabulous. We have so many here. So we have that first piece right here, second piece, third piece, fourth piece. What other color can we use? We'll use green. And finally, our fifth piece. We already had green. Dark green and light green. So for our red piece, our domain, again, we're talking about our X values for this piece. So when we're talking about our X values here, we start at 0. We're going to include 0 because that value is there. Is where we're starting at. The slope of that line is where we would find this piece. And we would go all the way until our second hour, which we would include as well because we would use the equation of this line to get that piece there. That's our first piece. And then our dark green piece, which I'm erasing them as we do them so I can see them a little better. So it starts at 2, but we're not going to include it because we would use the equation for that first line to get that 2 right there. And that piece goes all the way until our fourth hour, which we would include here because we would use that equation to get that part of the line. Our orange piece, which is that little horizontal line right there. So we would have our fourth, it starts at our fourth hour, but we're not going to include it because we're going to use our equation from that previous line. And then we are going to include it for our fifth hour there. Now let's get back to purple. For our purple piece, We were moving like crazy. Start at 5. Not going to include it because we would use that previous line. We are going to include 6 here, though. And then finally, for that light green piece, start at 6. We're finally going to end at 8. And so our domain is accounted for every piece here. So we have all the way from 0 until 8 accounted for in all those pieces there. Okay, so hopefully y'all are feeling more comfortable with writing a piecewise function. So I'm going to write the final answer for this piecewise function. And if you have any questions about your work, you can take a picture of it and send me a message on Remind, and I will let you know if you got it, where you went wrong, if you didn't get the correct answer. If you got the correct answer, you're probably good. But I'm probably going to write this over here because it's going to be a little bit bigger. I may even have to scroll down a little bit. There we go. We'll do that. So for our first piece, our equation is 15x, and that is for 0x to 2. Our second piece is negative 5x plus 40, and that was, I believe, for 2x to 4, and that 4 is going to disappear, so I need to move all this over. Actually, you know what? I'm not going to move it over. I'm going to underline this in green, so that's the domain that should be there. Then we'll have that 20, and that is for that 4 to 5 piece. And then we have 15x minus 55. That's for the purple piece. And then lastly, we have negative 35 divided by 2x. The x is out to the side, but divided by 2 times x plus 140. And that's for that final piece from 6 to 8. Which, and again, I'll underline that in lime green so you know what domain goes there. And then finally, our final question is, at what times was the bus driver 20 miles from home? So let's scroll up and look at our graph. And I'm going to make this, oh, it's already small, perfect. And I'm going to highlight when we're 20 miles from home. So how I would like for you to answer that is that we are 20 miles from home for part of our first piece. And then for our third piece, you can just write the entire third piece there. And then we are again 20 miles from home in the middle of our last piece. And we had 5 pieces. So you can also just say part of the 5th piece as well. All right, guys, so that's the last question of this review. If you have any questions, message me on Remind. Your test is going to be linked in Kitim. It is on a Microsoft form. I will try to have grades to y'all within a couple days. Actually, my goal is to have them to you by Friday afternoon. Hopefully, I'm able to accomplish that. It may be Tuesday when we get back to school before I'm able to enter them in. But go ahead and take your test if you feel comfortable taking it. If you don't, send me some questions and Remind, and we will go from there. All right, good luck on y'all's test.